Hi, thank you, everyone. Thank you for joining our Clean Energy Technology Adoption Panel today as part of our Industrial Tech Conference hosted by Maxim Group on our mvest.com platform. Also, I'd urge you, audience members, scroll up a little bit on your screen. You'll see a button on the top to request a meeting from any of the companies participating in our panel. And then also there is a separate button for you to ask a question if you would like to do so during our conversation. I think it's the clean energy technology adoption. These are great companies on our panel introducing new technologies in many different countries. So I'm looking forward to our conversation and learning about all of their technologies and products. And it also follows up our last panel about solar project development trends that we heard about from the actual customer perspective. So let's jump right in with our company. So introducing in alphabetical order by company name. From Ascent Solar Technologies, CEO Jeff Max. From EcoWave Power, ticker WAVE on the Norway Stock Exchange, and on the NASDAQ, CEO Ina Braverman. And from Ocean Sun, ticker OSUN on the Norwegian Stock Exchange, CFO Carl Lawinius. Thank you very much for joining, everyone. As a way of starting our discussion, let's just rotate around again by alphabetical order by company name. Starting with Ascent. Jeff, can you start our panel discussion today by providing an overview of your technology, about your solar panel technology? Where are your facilities and your product development located, and how you're going to bring your product to market, or is it already in the market?
Sure. Well, thank you, everybody, for joining us today. So Ascent Solar Technologies is actually an entity that's been around for probably in some form or another for close to 20 years. It started as a skunk works kind of think tank at Martin Marietta about 2 decades ago, and was spun out and ultimately went public in 2006. The technology that we've focused on and invested over the years close to $400 million in is flexible thin film solar modules. So what I'm showing you here and what I have in my hand is actually a solar module. And we like to talk about this material as solar for any place where rigid panels don't work. We're very familiar with the rigid silicon-based panels, their utility, and in fact, in many cases, some of their drawbacks. And what we're finding is that the flexible, lightweight material that Ascent produces can be produced in an infinite variety of shapes, of sizes. It comes off of our manufacturing equipment in rolls, roll to roll, 1 meter in width by 1 kilometer in length. And we really see it as a perfect adjunct to the rigid panel sector of the industry. So any place where a rigid panel just really isn't the right solution. It doesn't mean that solar is out of the equation. It just means that a flexible thin film alternative is an interesting way to go. We are and have been headquartered just outside of Denver, Colorado, in the States, and we issued a press release about 2 weeks ago indicating that we're closing in on a transaction to acquire assets of a very large European-based player in the same space, which would dramatically increase our output capacity as well as revenues to the business.
Great. Thank you, Jeff. And Ina, shifting to you at EcoWave with the best ticker probably for your business, Wave. Can you talk about what you're doing with wave power generated by the ocean that has never been done before?
So EcoWave Power developed a unique proprietary technology for generation of clean electricity from ocean and sea waves. What EcoWave Power is actually doing different is that we're showing that wave energy generation is actually possible. 99% of the developers in the wave energy sphere decided to go into the offshore, meaning 4 or 5 kilometers into the sea. Like basically installing these large, bulky floaters in the middle of the ocean and putting all the expensive generators and the hydraulic equipment, all the conversion equipment inside the generators. inside that floater, sorry. This created multiple problems that were really impeding on the commercialization of wave energy. The prices of offshore wave energy was sky high. It would break down all the time because when the waves are too high for the system to handle, it would be total loss to the system every time a big wave would hit, basically, because all the expensive equipment is inside. Environmentalists were objecting offshore wave energy because it created a new presence on the seabed, which disturbed the environment. They had a problem of connecting to the grid because, again, when you're offshore, the grid has to be put underwater. It becomes very expensive. It becomes very complicated. And again, in between the high prices and the breakability of this kind of equipment, they never got there. What EcoWave Power did difference is basically that we don't go into the offshore. We install on existent man-made structures such as piers, breakwaters, jetties, and other types of structures. The only thing in the water are the floaters, which belong in the water, and all the expensive equipment is on land, just like a regular power station. So basically, this enables us a very competitive price quote. For comparison, a company called Pelamis in the past built like a very small few hundred kilowatts power station for a development cost of over $150 million. We built the same for $450,000. That's a big breakthrough in terms of the price. The reliability is high because, as I said, the only thing in the water are the floaters. So when the waves are too high for the system to handle, the floaters automatically just rise above the water level and stay in the upward position until the storm passes, similar to wind turbines. When the wind blows too strong, the turbine simply locks down and stop operation and prevents any damage to the system. We're fully insurable by reputable insurance companies. We're 100% environmentally friendly since we only connect to existing man-made structures, which already kind of infringed on the natural environment. So we take something that damaged the environment and turn it to a source of clean electricity. And we have been connected to the grid for 6 years in Gibraltar with no problems, showing that wave energy can connect safely to the electrical grid. Now we're opening our second grid-connected power station in Israel in collaboration and co-investment from the Israeli government that recognized us as pioneering technology, and EDF Renewables IL, a subsidiary of Électricité de France. And we have a quite large project pipeline of 400 megawatts up and coming. The newest one is 150 megawatt deal, a $150 million deal in Turkey of 77 megawatts that we're planning to install in the area that is called Ordu in Turkey, plus additional agreements as concession agreement in Portugal, in Spain, and in other locations around the world. So we're showing wave energy is possible, and we're slowly and safely moving towards the commercialization of wave energy, which I think is very new and exciting. And I hope that people will follow our journey.
Thank you very much, Mina. And Ocean Sun, another good ticker for your technology, OSUN, can you talk about the history of your floating solar panels and how the technology was developed and where you can apply your solution around the world?
Yeah, sure, Tate. Well, first of all, just a short mentioning of why floating solar is important. So basically, solar will be deployed in the massives going forward. You have 5,000 gigawatts needed before 2030 to reach the climate goals. And that requires about 15 million football pitches of land. Land that is hard to come by and hard to devote to solar power generation, especially when you're close to where it's consumed and close to where you have existing grid. But looking to the water, you have tons of available water space. So there is an opportunity to put the solar panels on water. And when you want to do that, you want to create the most reliable and cheap deck that you can produce to support the solar panels. And that has been our focus in Ocean Sun from the start in 2016. So floating solar started, 10 years back, basically by just putting solar panels on pontoons, which are quite flimsy and subject to fatigue and also quite expensive. We looked the other way around and we started with this deck and how can we produce the most affordable deck to support our panels. And we did so by looking to Norwegian fish farming, where they have these fish pens created from HDPE pipes. And they are very robust to waves and have very low wind fetch. So they deal very well with the environmental loads. And we have spun from that and decided to apply a thin membrane, a tensile membrane that supports the panel. And this way we can put our system basically anywhere where you would want to deploy solar cells. So we can go on inland lakes and reservoirs, near shore or even offshore. We have our most exposed system is in the Yellow Sea. So you find 10-meter waves and large winds or strong winds.
And waves, yeah, thank you very much, Carl. And we'll circle back to learn more about all your projects in different countries too. And can Jeff, back to Sensolar, can you talk about that potential applications for your thin film solar? Your website shows airplane wings, for instance. I mean, can you list some other applications, and ultimately will your product be on rooftops for houses?
Sure. So, you know, our genesis as a company was really developing low mass solar for the defense industry. And so the use in space is well documented. On the satellite side, we have been deployed in NASA tests for quite some time, and the material proven to withstand the intense radiation environments and extreme environments that one finds in space. We're currently baselined for CubeSat deployment by the Japanese space agency JAXA, and have well documented deployments on high altitude airships, as well as deployments on the top edge wings of drones. I think I showed up an image to Tate, and I'm inclined to try and do that now. Just stand by for a second. Sorry. So this, sadly, you can't really see much of it or the full size of it, but this is the actual wing of a drone used by the U.S. Coast Guard for surveillance and reconnaissance missions. And by adding a layer of our thin film solar to the top edge of the wing, the aircraft gets a 50% increase in airtime, which is, a considerable uplift in that industry. As I said earlier, the fact that this material is so flexible that we can modulate it in any range of voltages, in any shape that fits the use case, we have, really an unlimited universe of use cases, right? I just came back from a trip to Asia, and we were requested to look at the deployment of this material between the tracks of a high-speed railway system, right? There's the track width is 1.5 meters. The material is 1 meter wide. There's 350 kilometers of this high-speed rail track that's unused today. You can lay this material between the tracks. And again, this is a way to capture solar energy in an environment where a rigid panel simply wouldn't work because of vibration, because of breakage, because of its delicacy. This material plays. When it comes to rooftop application, we're all familiar with solar panels on rooftops, and it's the most obtrusive and architecturally violative installation you could imagine. It's like putting up an outdoor advertising sign on the top of your roof. Well, with a material like this, we can deliver it, and we do deliver it with an adhesive backing. You remove the adhesive backing, and literally, apply it to a rooftop, whether it's commercial or residential, it retains the architectural integrity of the rooftop while delivering, power as you would have from a rigid panel type of solution. So, it's kind of a fun opportunity. We are not in the business of end use applications, but rather delivering this material to manufacturers, to VARs, to resellers, to installers who have or can come up with, a new and interesting approach to how this material can be used.
Great, all great examples and great, but on the railroad tracks, it's one I would not have thought of it. And as for your one thing, when we talked before, I didn't realize how many potential applications for, is it the right terminology, floaters. Can you give it, is it all piers? Is it piers in use? And what are breakaways? Are breakaways all over the world? And where can your floaters, be?
Yeah, well,
Yeah.
Go, Jeffrey. You want to say something?
Or did you have a follow-up?
Tate, who did you address the question to? Sorry.
Oh, sorry, I was shifting to Ina, talking about where
Ina, go.
Okay. So basically, our technology is very compatible to any type of structure that is already located in the water. Any type of breakwaters, piers, jetties, floating and fixed platforms, can be even offshore drilling platforms, gas drilling platforms, oil drilling platforms, such as the one installed by Chevron or Total. Wind platforms, offshore wind, you can attach wave energy and achieve much more stability in generation. And, we have kind of right now endless amount of these breakwaters and these structures all over the world, because, with the climate change, the rising of the water level, there is much more stormy weather. So not only that you have a lot of existent marine structure of this sort that are meant to protect the coastal population and the ports, but also you have many, many new structures of this kind being built and developed all the time. Now, these structures, again, they have a big positive. The positive is in the fact that they're protecting the coastal population and the ports from stormy environment, preventing damage to the population. On the negative side of these structures, they're creating a very negative environmental footprint because, a lot of stones in the water or cement in the water is not something that's exactly positive and natural. So we're taking something that is already there, that it's not prime real estate, like you can build a hotel or anything like, nice or expensive on a breakwater, and we turn it to a source of clean electricity. Now, our technology is very smart. It's starting to operate wave heights of 50 centimeters, like half a meter and higher. Most of the coastal countries in the world, meaning that are open to the seas or the oceans around us, they have this type of wave height. Also, 2/3 of the world population are currently living on the coastline, about 200 kilometers away from the coastline. So with this type of population distribution, the need for wave energy is undeniable. We can save a lot of the transmission costs. And even if we're looking by the projections of wave energy, we see that according to the International Energy Information Administration of the United States, wave energy on its own can provide 66% of all the United States energy needs. Like, that's a huge amount. And if President Biden is serious about his intention of going net zero carbon emission by 2050, and right now the US is maybe at like 20% production, if I'm not wrong. So you have here a source that can be 66. I would definitely make a turn together with solar, of course, and with wind, not as a sole solution, because the solution is in all renewable energy sources, but I would definitely put an emphasis on wave energy. And the good news is we can see a very positive shift and progress. New Jersey just applied for a new legislation initiative of implementing about 700 megawatt of wave energy for the first time as part of Governor Murphy Energy Master Plan. California has just submitted a new, Senator Padilla just submitted a new legislation initiative, I think yesterday, also to dedicate more attention to wave energy. So wave energy is definitely an up and coming source, and again, which will be highly compatible with stabilizing solar, with stabilizing wind energy, with creating, a possibility for the world to be really actually 100% depending on renewable energy sources. And this is something that we all would like to achieve. And I would take this opportunity also to talk to maybe Carl and Jeffrey offline as well, But one of our recent patents is actually combining floating solar on top of our floaters, because our floaters are quite large. So you have a very large kind of not used space, because again, all our expensive equipment is not inside the floaters. So I would love to talk to both of you, especially saying that, you know, your solar panels can survive very difficult winds. And I saw Carl level 4 winds and waves. So in your website while you were speaking, so I would definitely be glad to talk to you and see maybe how we combine you in some of our upcoming projects.
Oh, great. Yeah, well, I'll link all of your contact information too, if you all don't mind. I mean, that's a great example of all the clean energy, new technology adoption and clean energy that, I mean, you can, I personally can foresee that your products will be all over the world. And I mean, I hope to have time to hear from all of you about how different countries are more willing to adopt your products as well too. And then Carl as well, and they sure to circle back to you too. You mentioned, I believe in some of your recent materials being utility scale projects now. Is that, so now you have the technology to fill an entire reservoir with multiple rings of floating solar, or is this how recent the development is this?
Definitely. The project you're referring to is perhaps not utility scale, but it proves our ability to serve utility scale. So it's a 2 megawatt peak system consisting of 4 floaters. So our floaters are each individually about 700 kilowatt peak. And then you can add the amount of energy that you need by scaling up the amount of rings. And then you pack them close together. So it's a very, very good power density in the system. And that's a system we have installed with a large European power producer called Statkraft, one of Europe's largest renewable energy producers. And it's basically 4 floaters, sits on a hydropower reservoir where we see perhaps the most potential for floating solar, as it's a very good synergies with the hydropower. You can use the existing grid that is built out for the hydropower and produce solar during the day, and then use the hydropower for what it is, a very good way of balancing electricity and providing electricity as a balanced electricity when there's no sun or no wind. And these systems, these hydropower reservoirs, are typically dimensioned to feed on full power. You know, but if you would run them on full power, they would run out of water in no time. So basically, there's always overcapacity in the grid.
Is your, and what I mentioned earlier, shifting to talk about and staying with you, Carl, too, is have you sold, are most of your projects in Norway and Europe, and are European countries much more willing to adopt your new technology compared to the US and other countries at this point?
I'd say we don't have that much power projects in Norway. There's a little bit of lack of sun in Norway, so that's a poor fit. But we have a lot of knowledge on the ocean and ocean structures, and that's where we come from. And but we operate globally. We operate as a technology provider. So we basically offer our technology to power producers or EPC companies around the globe that has the local knowledge and local manpower to realize the projects. So with this quite limited business model, we can have a very broad geographical spread and work with right away. Even though we're a small company, we can work with very large projects and utility scale projects.
In terms of guiding them how to use or construct your floating solar panels, is that? Yes.
Well, first of all, we have this is all patented technology. So the first thing we do is allowing the IPP to use our technology. And then with that comes guidance on how to install it. And we design the system to cope with the environmental forces on the site, to cope with, for hydropower reservoirs, you have a lot of water level variations, which you need to cope with. And we also supply suppliers for the key materials in the solution.
And Jeff, did you mention at part of your opening comments or a bit later about acquisition of facilities in Europe, I believe? And do you see more of a market in Europe compared to the US for your technology, or did you want to comment on something?
I see tremendous potential in the US. I don't see much immediacy in the US, to be honest. You know, we saw the EU directive that came out last week about clean tech and clean energy. As I said, I just came back from a tour of APAC, and these are actually markets and environments where legislation is driving adoption. In the US, you know, there's a lot of excitement and frenzy about the investment, the Inflation Reduction Act and all the money that's available. But what's interesting here is there's so much land, there's so much available space in the US, and there really isn't the kind of urgency that we find in European markets. There isn't the urgency that we see certainly in Asia Pacific markets for clean energy. You know, I'm seeing the demand in those markets off the charts, where the US, you know, is lagging in actual efforts for adoption. It's not at the commercial scale, or the really getting the kind of, in my view, the kind of really legitimate focus that you know that the climate situation implies.
Well, thank you. And Ina, would you echo that? You mentioned that you have existing projects in many countries. Is it easier to sell your new technology in some countries compared to others? And
we're seeing yeah, no, look,
company too, and you've dealt with many companies. Oh, yeah, I started saying.
Yeah, we're seeing adoption. We're definitely seeing adoption, easier adoption, more aggressive adoption in other markets than the US. We're certainly here, but in the US, the interest has been historically more on esoteric kinds of things, aerospace, aeronautical kind of applications, where this has real terrestrial use, and we're seeing that demonstrate itself in Europe and APAC.
Would you echo that, Ina, as well, too?
So what I would say is that definitely Europe, in terms of wave energy, in my field, is definitely leading in terms of wave energy legislation and policies. Like, for some reason, Europe just started earlier. You know, countries like UK, Scotland, Ireland, and so on, like, invested tremendously in the research of wave energy. A lot of the countries there already have feed-in tariffs and regulatory frameworks and so on, which just makes it a little bit regulation-wise easier to implement a project. However, with that said, I see the US as a huge market, as a huge opportunity, and you know, anything that happens big in the US, even if it takes time, happens big everywhere, not only in Europe. Like, people are looking up to the US. What is the US doing? So yes, I understand that in the US, like, it might be sometimes more bureaucratic. Certain legislation has to pass before we can actually implement. But with that said, the level of excitement is very high. The level of the commitment right now of both local and federal government is very high. And I really believe that once we open the first project in the United States, which has been our core focus together with the European market, it will kind of create, you know, a positive snowball. Because again, it happens in the US, it's like all over the media, it's all over, like, one state does it, many states following. So it really creates some positive impact that we do not necessarily see from other countries.
Carl, we started with you on the conversation. Do you have projects under development in the US, or have you already placed your technology in the US, or has it been easier? It seemed like dealing with Europe.
I think I agree with what the others said. We have some early stage developments in the US. We see definitely the interest is perhaps biggest in Southeast Asia, Northeast Asia, where you have seen much of the floating PV installations. And you have a country like Singapore, for example, they have no land availability. The rooftops are already covered. They have no wind. So how should they create renewable energy? Yeah, they need floating solar, right? And as Jeff said, you have one benefit with the US is you have a lot of land. But what we see in the US is it can start from another point where we see that you have also large problems with water evaporation in water treatment facilities, in hydropower reservoirs as well. And when you put our systems on the water, you prevent the evaporation. So if you cover 100% of the reservoir, you reduce almost the evaporation with 100%. And that water is the most valuable resource of these facilities. And then you can, instead of like they do now, you pour out these small plastic pellets to reduce it. Then you can lay out one of our systems and put solar panels on top. And then as a byproduct, you generate clean electricity. So that's something we see a lot of interest from the US now.
Great. I mean, all your technologies, should resonate in my mind with customers to investigate them. But I mean, what I'd love to hear about one of our previous panels referred to a risk of technology risk, a fear of adopting new technology. How do you get potential customers over that fear? I mean, Jeff, you're talking, it sounds like, to mostly distributors for your product. Do they say that they're worried about the technology, the proven aspect of your technology?
No, and I think it's a function of the fact that this material has been around for a while, and the experience and the bona fides that we've developed over years in space has really sort of addressed any concerns that people have about durability, about performance, about long-term performance. It's one of the issues with rigid panels, even though they're widely distributed, is durability. And vibration can crack them, hail can crack them, rocks can crack them. And so, and when you do, you lose a large, square meterage area of productivity. With the thin film material, any damage that takes place, and it's hard to damage the material, really only impacts the location of the damage, not the entire panel itself. So I think that technology adoption, technology risk is not an issue in our space.
What are the roadblocks for customers? And I think in our previous conversation, most of your potential entities that have the right to put your technology on breakwaters are government organizations. Is that correct? I mean, so why don't they quickly adopt or use your technology? What are the roadblocks?
So technology-wise, the technology readiness level is high, so that's not a roadblock. Really, the breakwaters, like I said before, they're not prime real estate, and they're owned by ports or owned by the municipalities, so they can use it freely. So that's not a roadblock. I think the two kind of, let's call it showstoppers or temporarily showstoppers for wave energy is one, in the fact that really there is lack of licensing procedures, regulatory frameworks, more like kind of bureaucratic problems for wave energy. So many times, for example, a port or a municipality or a state sees our technology and they go, wow, it's super easy to implement, it's super fast, we want it, let's put it, and we get all excited and we go, okay, how do we start? What do we do? Which licenses do you want? And then they go, we don't know. Let us legislate, So it can be as little time as 6 months to really build a pilot, have an operational pilot in place, and as long as 2 years to make the legislation, the licensing framework for it. Again, it's not a pleasant problem to have, but on the other hand, in solar and in wind, when they started 20, 30 years ago, it was the same situation. One country legislated and then the other one copied and the other one copied, so slowly and safely, this problem is being solved. And I think that the second type of problem is the fact that really, because wave energy is a new technology, it's still not entitled for debt financing. Right now, most of the large-scale projects in solar and in wind are being in majority financed by banks. Sometimes solar projects I know can even get to 90% funding from banks in very comfortable terms, at least before the financial crisis that made the interest a bit higher than usual. Regarding wave energy, like it's getting there, but it's still not there. So what happens is that we basically fund our project either with equity or with grants, and grants are not always available at the time that you have a ready-to-build project, that you have an available project for construction. Equity is like kind of the most expensive type of funding that one can have. So what happens that instead of building like multiple yielding assets or multiple wave energy power stations in parallel, like right now we're kind of going slower. So we're building one, stopping, raising money or getting a grant, building another, and like we kind of go slower. With that said, like I'm still, maybe being an entrepreneur, I'm still very optimistic about the situation because again, wind and solar faced exactly the same problems when they started, both in terms of debt financing, both in terms of regulatory frameworks. And right now, wind and solar are one of the largest industries in the United States. The most jobs have been created in recent years is technicians for solar and for wind farms. And I see wave energy definitely heading in the same direction. So like, I definitely see that there's problem, but I definitely see them being solved in the near future.
Great. And Carl, are you selling most of your, who are you selling to? Who are developing your projects? What the EPCs are executing them, but is it the local utility that will decide to put it on the reservoir by the hydropower plant, for instance? And what is their resistance to using your technology?
Yeah, it's typically the in the case of a hydropower reservoir, it's the IPP owning the reservoir, or it might be global IPPs working traditionally in solar, expanding their expertise also into floating solar. It might be an energy-heavy industry wanting to produce clean energy to use in their facilities. So it can varies a lot depending on, and I think the market for rigid panels is quite traditional. You still use the same principles that were established in Germany 30 years ago. And we come in and we radically change this. We don't use the 4-point clamps. We use the Keeler principle. We put these on water, which has been a big no-no previously. So, but that's starting to mature. And we see that the technology is getting better. Some of the existing technology, not our solution, is perhaps not fit for purpose. So we definitely have had a need to prove ourselves, to validate our technology. We've engaged with multiple verification institutes like DNV to get confidence that this solution is bankable, basically. And now the main obstacle is legislation and the permitting process, which I think, from what I hear, is a big obstacle for all renewable power generation. The permitting process is too slow in large parts of the world.
Similar to what Ina mentioned, does the permitting process have to be almost invented for your technology in some countries?
It has been in some markets for the first time. Yeah, definitely. But I think now the several states and several regions, Europe, for example, are getting their eyes up for floating solar. And I'm hoping and thinking that in the coming years, there will be prone to more adoption.
Well, it's great to hear from all of you. I mean, you have global opportunities and big picture technology that can transform clean energy. So I really appreciate you all coming together and sharing more details about each of your companies and the different markets and technologies you have. In the interest, I just wanted to make sure that we have enough time to circle around for any closing statements that you'd like to give. Did we not touch on one element of your story that you want to highlight to investors, or circle back to any of your comments? And Jeff, I'll start with you. Any closing comments?
You know, I think that for all of the participants, all the panelists today, it's really interesting because we see we see different approaches and different technologies and different visions for attacking this problem. And the solution lies in all of it. There isn't a single alternative. There isn't a single solution. And yes, legislation is a challenge in some markets, less in others. But really, I think, ensuring that there's adequate capital flow to these companies so that they can expand, so that they can continue to develop the technology is super important. And I come from a career years ago in the software business, and it's an interesting play there, because you'd have an idea, you'd do your focus groups, you'd go out and build product, come back and hope that the market hadn't moved away from you, that there was still demand. In the space that we're all in, we know that there's nothing but exploding demand for these solutions for the next 50 years. So, it's a very exciting place to be, and it's really exciting for me to see all the innovation and enthusiasm and inventiveness from these other founders and CEOs and technologies. Terrific.
Thank you very much, Jeff. Ina?
I would like to finish maybe by saying that I truly believe personally, again, I'm not so objective, but that wave energy is the future. Wave energy is just in the beginning of its commercialization. I think that EcoWave Power is right now on the forefront of technology. We're kind of the only company that is actually constructing, connecting to the grid, signing commercial scale agreements, 20 megawatts, 70 megawatts, and even larger agreements. The interest is on the rise. I think everybody right now understands much more than in the past the importance of renewable energy. If we're looking at the situation in Europe, in line with the war between Russia and Ukraine, when Russia holds a lot of the power production of Europe in its possession, Europe has clearly understood that it needs to go much more independent and put much more effort and emphasis on renewable energy. The new government, or relatively new government in the United States, understands that as well, with the Inflation Reduction Act and with other means of support that are being put for renewable energy. And I really, really think that wave energy is something that we should pay attention, because it was kind of a neglected topic for many, many years, because really companies in the past went where it's too expensive, where it's too complicated in the offshore, which kind of created a difficulty. We're making it smart, we're making it simple, we're making it cost efficient. We're actually constructing at the moment that the regulation will kind of open up and that financing will open up. Wave energy is definitely a huge, huge source of electricity. If we're looking on global scale and not only on the United States, according to the World Energy Council, wave energy on its own can provide twice the amount of electricity that the world produces right now. It has 832 times density of air, meaning you can produce much larger electricity amounts than wind with much smaller, thus cheaper devices. So it kind of has all the natural advantages, from Mother Nature. So I definitely would like, whoever listens, to join our journey of changing the world one wave at a time, because we're really doing something new and pioneering and revolutionary.
Thank you very much, Ina. And then Carl was a great point too. Not only are you generating electricity, but you're helping preserve the water, conserve the water reservoirs too. And any other closing statements that you'd like to bring up?
Yeah, definitely. I'll just continue with the wrapping up investor pitch. So I agree with Jeffrey and Ina that all power sources will be needed. Energy analysts, they largely agree that solar power will be the dominating source of electricity going forward. And then the problem will be to find suitable deployment space where floating solar is an opportunity. And within the floating solar space, Ocean Sun, we have the best technology, offering the lowest cost and the most robust solution, which is why we think that we will have a great journey ahead of us.
Well, it was a great it has been a great international panel, and hearing about all your technologies and opportunities. And thank you for all your perspectives as well. And I look forward to hearing about all your company's progress. So thank you very much for joining us. Thank you to the audience as well too. Have a great
Thank you,
day.
Tate.
Thank you. Have a nice day.